So let us start. Rust code prototyping using XML, or what I shortly name as rustxmlproto, is inspired by Google protocol buffers. I made this tool to generate Rust code easily from XML data. I started this project a few months after I learned about Rust, and this I've done to explore more about the language itself. So first of all, what is a protocol buffer? So a protocol buffer is an open source cross-platform project that is used to serialize structured data that can be transmitted or stored in files. Protobufs, however, are much faster than XML and JSON. You can see from the left image an example of how protobuf is defined. So in this definition, we have person as our object with members name having string data type, ID with int32 data type, and email with string data type. On the right side, we can see how it can be used in the code. So it builds the person name, John Doe, with values 1, 2, 3, 4 for ID, John Doe for name. Email is jdoe@xml.com, and then for protobufs, it uses the function build to generate the structure for this object John. And then afterwards, it writes the object into a file output stream. In our project, XML structure or format is used for the prototype instead. Now, rustxmlproto's main objective is to create a tool or library that can auto-generate Rust code from struct, traits, enum, and other object definitions by modeling them through XML. There are other auto-generating tools for code that I've encountered, starting from my previous company that I joined until the current company, but I haven't seen anyone yet that uses Rust language for it and for the purpose of generating Rust code. So here's a preview or example of how the XML format is defined for a Rust object in my project. I will describe the XML elements, tag names, attribute names, and attribute values in the later video, in the later slides. And here is how to use the rustxmlproto object in a module. You only have to use import proto macro function with the object name as a parameter. So we have import underscore proto with value foobar as our object name. Now I am going to describe the main or major XML elements for our object definitions. We have the root element that needs to be defined as the prototype. This is ultimately required so as to set the object name of our structure. Without this element, the XML data is invalid itself. Next, we have prox. Prox, I shortly name it after the procedural macros. It is literally used to define the procedural macros and custom macros. Next, we have members. Tag name members. Like any other object or structured data, we need member variables. So this we also have to define through members element. Next, we have includes. Includes, with this element, we can use or import libraries from external or within the module. And lastly, we have functions. Apart from setters, getters, and constructors, which are already automatically generated after we run the rustxml tool, we can also declare other functions that we intend to use. If you want to add another function name, integrate with foobar, or whatever you want. Next, let's discuss the attributes of prototype element. So in our prototype element, we have the attributes name, which is the object name of our prototype. This will be also used to name the module itself. So if you have foobar, then our module will name as module.rs with .rs our extension file. Next attribute is class. It defines the type of our object. So in class, we can define that our object can be struct, enum, or trait. Visibility. Visibility describes the visibility of our object. So we can have mod, which means that our object will be only allowed to use within the module, or crate if you want to use only the object inside our crate, external if you want it to be used externally, and globally and private, the same as mod within the module itself. Next, we'll discuss the child elements of includes. So we have includes, we have these child elements as the following. Within will define that the imported modules comes from within our crate. Extern describes that the module we imported is from an external crate. So here's an example. We have includes, tag element include, and then within that includes you can have a lot of multiple instances of within or extern. So within foobar within, and the module is foobar within, and then for extern we have the module foobar external. Now we have to discuss the attributes of the child elements. So in within or extern, we can define the scope. If defined as all, so all objects in the imported module can be used independently. However, if you want to specify which objects you want to use from the module, you can use objects with a set of values like object 1 and object 2. Now let's go to members and functions. So for members and functions, you have the child elements. The tag name of the child element within the member can be any string that refers to a data type. For this example, we have string data type for our object name item. Then we have U32 as our data type for object name pride. So another attribute or attribute associated with members and functions is we have visibility. Like other visibility values, we have mod for within the mod crate if you want only to use this one inside the crate, external if you want to access it externally, globally, and private, the same as mod within the module itself. In functions, there is a subnode that can be defined for parameters. So we all know that functions or methods have the parameters or arguments that will be passed from another instance. So here we are. Parameters. The child element of a parameter is any string that refers to data type. So here, like functions or like members, we can define the parameters with string, data type U32 for this example, and any string that refers to data type. Also, we have child attribute name. This only refers to the name of our argument or member or parameters actually. Next slide, we have XML elements for our macros. There are currently 3 use XML elements for macros. We have first derive, so it defines new inputs for the derive attribute. Serde, if you are familiar with serialize and deserialize, you can use Serde to generate implementations of these traits. And then custom, if you have created customized macros or other macros other than derive and Serde, you can define them under custom XML element. In procedural macros, you can also indicate a set of traits. So if you want to use a lot of values inside, for example, derive, you have to define it by using the attribute set. Now, for our demo code, here's a example for the XML prototype I created for the demo code. We name it as testproto.xml since our object name is named as testproto. So here we have prototype as our root element. Without this, you cannot generate the Rust code. Then we have the name attribute testproto class. So our object type is struct. And then the visibility, this object can only be accessed inside the crate. After the prototype tag element, we can see the includes. So this imports any module you want, any module that we want to use inside our project. So for example, we have here external name using std derive. So we are using std derive as our module. Then with object specified as deserialize and serialize. Okay. Next, after includes, we can also define procs. I define here procs, procedural macros, using derive as our XML element. And then inside derive, we can define a lot of traits, for example, debug, serialize, deserialize, and okay. Lastly, we have members. So we have to set our members for our object struct. So in our example, or in our project, we have string data type for object name, member name with visibility external. So this can be accessed externally. String name, string data type for object for member current address with visibility crate. So this member can only be accessed inside the crate. And lastly, I32 data type for member ID. So if you don't define the visibility of the member or any object, for example, here you don't have to it's not necessarily uh, to have a visibility attribute. So if it's not defined, then it's automatically within the module only. So to use our prototype testproto object, so it is as presented. So in main.rs, created the main module as main.rs. We have first the use proto macro import proto. You will use this so that we can import our proto object. After that, we use the macro function import proto and then our object name testproto. Then inside our function name, we have print. We print first that we run the demo for testproto, and then we use the constructor of testproto. So here it is. Now we can use the generated code. Object proto with testproto double colons new, and then you have our string number Joe Biden, and then for this is for a string name Joe Biden, and then current address for our object is White House, also a string data type, and then ID member ID is 123456789. So after that, yes, here's an example of how we test assert the values inside our object. So we can use assert equal and then get the name of our object, compared it to a string Joe Biden. So if it is if it returns true, then it passes, right? And then if it passes, it will print our string test case proto name Joe Biden passed. So if it fails, then it will stop here and skip the uh, remaining lines. Next, we also assert equal. We compare our current address with the string White House. So if it passes, then it will print that test case 2 passes with proto current address as White House. If it fails, then it will stop here and skip the remaining lines. Then next, we also compare the ID of our object with the value 1, 2, 3, 4, 5, 6, 7, 8, 9. If it passes, then it will print the test case 3 pass with proto ID 1, 2, 3, 4, 5, 6, 7, 8, 9. And if it fails, then it will just stop here. Next, so we have the constructor. We use the constructor of the generated code. Next, we will use the setters itself. We can use the setters and getters. I think we already used the getters. So setters. Let's say we change the name from Joe Biden to Donald Trump. So we can use proto.set underscore name with string Donald Trump. After that, we compare if the name is already changed with the string Donald Trump. If it passes, then it will print our test case 4 passed with name Donald Trump. If it fails, then it will stop here. Yeah. And next, we change the current address of our object with the string Washington DC. So next, after that, we compare again the current address of our object with the string Washington DC. If it passes, then it will print the test case value is passed. Next, we try to change the name, we try to change the current address. So lastly, we have to test if our setter for ID also working fine. So we use the set underscore ID to change the value from 1, 2, 3, 4, 5, 6, 7, 8, 9 to 9, 8, 7, 6, 5, 4, 3, 2, 1. And after that, we test if our ID changes from 1, 2, 3, 4, 5, 6, 7, 8, 9 to 9, 8, 7, 6, 5, 4, 3, 2, 1. So if it passes, then it will print that test case 6 passed with proto ID, the new value. And if it fails, then it will just print fail for test assertion. I think that's it for my presentation. If you have any questions, you can raise. Thank you.